Hi dear children, I am teacher Geeta. I have to give a lecture on class 11 chemistry topic alkenes. But before starting the topic, I want to say one thing. This one is showing that characteristic organic reaction terminology. So these are the terms that is very important in organic chemistry. You should be familiar with this one. The previous classes we discussed all these things detailed, and functional group, free radical, initiation, propagation, termination, nucleophile, electrophile, addition, substitution, elimination, hydrolysis, condensation, oxidation and reduction. So it's very important, you should be familiar with these words. Now the general characteristics of alkenes. Now the alkenes are family of hydrocarbons containing at least one carbon-carbon double bond. They are unsaturated hydrocarbons with the presence of the double bond. We have to say this is unsaturated because they have the carbon-carbon double bond. And this alkene, the straight chain of alkenes form a homologous series with the general formula CnH2n. I think all of you remember what is homologous series. From class 10 onwards we are studying that one. A series of organic compound with functional group with the same functional group with the successive members differing by CH2. And this alkenes, here I gave some examples of alkenes: ethene, propene, butene. The simplest alkene is ethene. The molecular formula, displayed formula and structural formula are given here. And the next one is the chemistry of alkenes. You know that these alkenes have many reactions in common with the alkanes, and their physical properties are, most of the physical properties are similar. I think you remember which are the physical properties of alkenes. They cannot conduct electricity. They are less dense than water. It's insoluble in water and dissolve in organic compounds, and it has low boiling and melting point. So most of their physical properties are similar. Now this alkenes undergo addition reactions because of they contain at least one carbon-carbon double bond. And this the alkene undergo different reactions with the hydrogen, with water, the halogen and hydrogen halides. The reactions of the double bond are very different. These dominate the chemistry of alkenes. Generally, addition reactions involve the removal of carbon-carbon double bond, and this carbon-carbon double bond is very reactive and can easily react to convert or react to form carbon-carbon single bond. Now the addition reaction with the hydrogen. These alkenes undergo hydrogenation. The reaction with the hydrogen is called hydrogenation. For this reaction, alkenes can be hydrogenated to alkanes, and the carbon-carbon double bond is converted into a single bond. And this reaction does not occur or does not readily happens without a catalyst. For undergoing this reaction, it needs a catalyst. Here it is alkene react with the hydrogen to form alkanes. An example is given: ethene react with the hydrogen to form ethane, and here nickel is the catalyst. And another example, propene react with the hydrogen and giving propane. But here also nickel as the catalyst. I think you remember what you mean by a catalyst. The catalyst is the substance that increases the rate of chemical reaction or speed up the chemical reaction without undergo any permanent chemical change. But that is the addition reaction with the hydrogen. Next one is the addition reaction with the steam. But this steam means the gaseous form of water. Actually the reaction with the water, alkenes and water. But this is called hydration. But what do you mean by hydration? Simply we have to say hydration is the interaction of substance with the water. But here, in the presence of an acid, water undergo electrophilic addition reaction with alkenes to produce alcohol. Here it is alkenes react with water, the product is alcohol. Ethene react with the steam or water, it forming ethanol. These are the examples I gave here. But this reaction is called hydration. The main product of this hydration is alcohol. But this has an importance in industry. The major way of manufacturing ethanol is hydration. For this reaction is very important. And the next two slides I add videos. Please watch these videos and understand. I hope all of you understand this lesson.
Quick question, why do you require a catalyst for hydrogenation? You know, when you're adding hydrogen across an alkene or a double bond, why do you need this metal here to act as a catalyst? Well, long story short, the catalyst is there to reduce the amount of energy required for the reaction to happen. This is the potential energy diagram for hydrogenation without a catalyst. You got your little reactants here. That means you have an alkene and you have your H2. And then when you're breaking open the double bond and you're breaking open the hydrogens, that requires a lot of energy. You've got to ramp up the amount of energy you have in your system all the way up here to break those bonds. Granted, once the two things react with each other, you slide back down, you get some energy out, and you end up with stable products. In this case, it's actually just an alkane. Long story short, they're more stable. But the problem is you gotta get over this hump. You gotta be able to break those bonds, and that takes so much energy. But because of this thing called a catalyst, we're actually able to need less energy, if that made any sense. Here's what I'm saying. You start in the same place. You start with your reactants. But then the alkene binds to the catalyst. That requires, I don't know, that much energy. That kind of happens. That's step one. Then the H kind of attaches itself to the catalyst. That requires some energy too. Settles down. Then the reaction actually happens. That requires some energy too. And then you've made your products. So rather than needing all this energy, oh man, that's a lot. You really only need this much energy. The catalyst binds the alkene and hydrogen to its surface and gets the reaction to happen in 3 smaller steps so that you reduce the activation energy down from whatever large number this was into this tiny little number here. It's less, and that's what counts. That's what makes it a catalyst. We're going to do some organic reactions, like what happens when you mix water with alkenes in acidic solution with a little bit of heat. Well, what happens is that the double bond of the alkene breaks open, and the water, which as you know comes as an H and an OH attached to each other, that breaks open. OH attaches to one side, H attaches to the other. The trick is that whichever side has more bare hydrogens on it, like this carbon has 2 H's, this carbon doesn't have any H's attached directly to it. Whichever carbon has the most H's gets the bare H from the water. Here's what I mean. Let's take a look. We got our 2 carbons in the center connected to each other. The second one has 2 H's on it. The first one had a couple CH3s on it. Now notice I've rewritten the double bond as a single bond because we've broken open the double bond. That means we can attach something to each carbon. The carbon that has the most H's on it gets the H in this reaction, and the OH attaches to the other one. You end up with an alcohol. And actually the alcohol we've come up with here is, oh, I guess I don't know. I don't want to have to name it right now. But I do want to point out that you can also do this in the stick figure form of showing the molecules, right? You got a double bond between two carbons. The carbons obviously aren't shown because of the way this is drawn, but that becomes a single bond. These two single lines represent CH3s, and you end up with an OH attached to that carbon as well. Now an H gets attached to this carbon here, but you don't show it because it's one of these stick figure things. Long story short, alkene plus water equals alcohol.